Hello everyone, welcome to the Equation Lab. Today we'll be doing a functional equation problem, so let's start with the question. So as I said before, today's question will focus on functional equations, which are a special type of equation that involves like f of x, f of y, stuff like that. So today's question is, find all functions f such that r to r that satisfy the following equation for all real numbers x and y. F of x plus f of y is equal to f of x plus y. So the term r to r means that if you plug in a real number, it outputs a real number. So using that information, solve this question, and I'll give you guys some time to get your answer. So let's plug in x is equal to 0. And plugging this in, we get that f of y is equal to f of 0 plus y. Now using that information, we can prove that f is surjective. Surjective means that its range spans all real numbers. So firstly, if you look at f of 0 plus y, as we plug in a real number for y, that is always going to equal a real number, meaning the same for the left side. So now using that information, we can say that there exists a real number c, such that f of c is equal to 0. So now we can plug in c for y. Now we get that f of x plus f of c is equal to f of x plus c. We know that we want f of c to be equal to 0, so we can plug that in, and we get that f of x plus 0 is equal to f of x plus c. X plus 0 just simplifies to x, so we get that f of x is equal to f of x plus c. And we can subtract f of x from both sides to get that c is equal to 0, which means that f of 0 is equal to 0. So we can plug in x is equal to 0 one more time, and we get that f of 0 plus f of y is equal to f of 0 plus y. We know that f of 0 is just equal to 0, so we can plug that in, and we can simplify the left side as well to get that f of y is equal to y, meaning that f is an involution, meaning that applying f twice undoes its effect. So since f is surjective, we can use our original problem statement and just apply f to both sides. So the f on the left side cancels out since it is surjective, and we get that x plus f of y is equal to f of y plus f of x. And then we can simplify even more because in our original problem statement, it said that f of x plus f of y is equal to f of x plus y, which means that f of y plus f of x is equal to f of y plus x. So then we can switch the variables, and we get that x plus f of y is equal to y plus f of x. And we subtract both sides to get all the variables, the common variables on each side. And we get that f of x minus x is equal to f of y minus y. So in order for f of x minus x to be equal to f of y minus y all the time, it must be equal to a constant. So this here states that for all x and y that are real numbers, f of x minus x must be equal to k, where k is a constant. So we can use f of 0 being equal to 0 in this, and we get that f of 0 minus 0 is equal to k, and this means that k is equal to 0. This means that we have gotten our answer. Our answer is that f of x is equal to x. So our question was, find all functions f such that r to r that satisfy the following equation for all real numbers x and y. F of x plus f of y is equal to f of x plus y. And we found out that f of x is equal to x. Thank you for watching, and make sure to like and subscribe.